Hello again, welcome to this second tutorial on Ghost. Today we're going to check out the Wavetable engine and every feature that it offers. Now let's start by stating what is a wavetable. Basically, a wavetable is a wave file that contains many different frames. In a wavetable synthesizer, you can go from one frame to another, and that will start changing the waveform and hence the sound. The more frames a wavetable has, smoother will be the movement. For instance, with this wavetable called Wars. Now, when we have small amounts of frames, the movement will not be smooth and will be choppy. For instance, with the basic shapes. This one has only 5 frames. Now, when you're playing with wavetables, you don't want that choppy kind of sound. So Ghost has this morph button that once activated will make it so each frame on a wavetable fades to the other. So now the basic shapes can be transformed like this. Now, if we go a little deeper on what's a wavetable, it's actually a waveform in a specific moment. So it's a waveform that changes through time. That's basically sound. So that's why almost every wavetable synthesizer can transform a wave file into a wavetable. In the case of Ghost, it's as simple as dragging and dropping. For instance, with this kick. This is great to build your own wavetables by resampling sounds that you have. Now remember that Ghost is an FM synth. So thanks to wavetables, we can start creating crazier kind of sounds with frequency modulation. That will give us richer timbres and even some complex and crazy results. Consider that a wavetable is also about movement, so if we change the frames with the morph on, the FM will also get that movement but in a different way, giving you a very complex result that's easy to program. Now let's go back to the oscillators to see the basic parameters. On the top left we have ratio. This will actually multiply the pitch of the oscillator in the harmonic series. This is because most FM synthesizers have that option, as going higher and higher on pitch will create very interesting timbres similar to bells. Below that we have the semitone control. Remember that 12 semitones is an octave. We can go 48 semitones below or above. And then we have the cents. 100 cents, it's 1 semitone. The cents are great to create this detuned kind of vibe. And below that we have another tuning, but this is the chorus tuning. We can change not only semitones, but also cents. Below the waveform we have the same oscillators that we can choose on the FM matrix, from A to F, and we can also change the phase of the oscillator. Very basically and oversimplified is like the starting point of the waveform. And as we are working with phase modulation, this will change the sound, and sometimes the change can be drastic. On the right, we have all the Unison parameters. That is increasing the voices, adding the tuning, changing the width, and enhancing the stereo even more. Now, if you're wondering why it doesn't sound like your typical Unison, the tuning from other synthesizers, it's because this synthesizer defaults with the retriggering option on. That means that every time you press a key, the oscillators will be retriggered and they will start on the same phase. In a FM synth, it's important to have it like that because the phase can change the sound, as I said, and having a random phase all the time will mean having different timbres. Now that can be something that you want, but the default is on retrigger. But if we disable it, now the phase will be random, and that will make it so the Unison engine sounds better, or at least sounds like you're used to. Now, as I'm speaking about the retriggering, we also have this direct out option. Right now it's not too relevant. It will become more relevant in the episode of the effects, because what this does is that the oscillator bypasses the effects. And before going to more complex kind of parameters, we also can pan each of the oscillators independently. Now, as you can see, we have these two knobs. The first one says bend minus plus, but you can actually change different ways on which you will warp the oscillator. The visualizer right here will show you the kind of change you're making. For instance, with the default bend, or with the asymmetry, the syncing, which is more common, and the window. At the right, we have spectral effects like low pass and high pass filters. A spectral shift and a spectral stretch. Now, I bet that you have been wondering what's the deal with having a filter and a distortion right here. And that's actually because this filter and this distortion are per-oscillator. What's even crazier is that these two effects come before the FM. So the changes that you make on the filter and the distortion, if you choose to use them, will affect the modulator if you are using this oscillator as a modulator. For instance, let's make it so B modulates A, and now let's start playing with the filter, which you can simply drag around. With higher resonances, we get a crazier result. The great thing is that we have a lot of different filters to choose from. Some are analog modeled, like the ladders, and others are for more experimental kind of sounds, like the phasers, the alpas, and the comb filters. I'm not going to go in detail for these filters, I'm going to save that for the effects episode. The same goes for the distortion. Again, we have a simple drive, but a lot of different types of distortion, from your typical soft and hard clippers to weirder wave shaping shapes that will start transforming the sound. For instance, an exponential distortion, or your typical sine folds. As you can guess, this is a wave shaping type of distortion. Now again, next episode is going to be about modulators, but right now let's use a simple modulator just so I can show you how you can create a growl. The basic of a growl bass, stab or whatever on electronic music. It's Wavetables and FM, so it's perfect to test it on Ghost. I'm going to choose this shape for the modulator and this other shape for the carrier. I'm going to use the LFO to modulate the movement, and just with that we basically have a growl. But if we start going crazy and, for instance, use a distortion with the same movement of the drive, we will get a different type of result. The same for the filter and other parameters like the bend and the spectral filters. So that's basically all about the wavetables. As I said, next episode is going to be modulation, so you can use all of this knowledge to create very complex movement. And of course, great sounding patches. See you next time.